an episode of the Balanced Weather science videos. It's been a couple of months since I've done one of these, and I'm really excited today to have a longtime friend and colleague, Dr. Dave Sills from our partners to the north in Canada, and we do have some Balanced Weather subscribers in Canada, including Dave, but a handful. So it's exciting to have an opportunity to focus this afternoon on some of the great severe weather work that's going on in Canada, and also talk about some not as great things that are going on in Canada that have some disturbing parallels to some of the things going on down here in the U.S. So, Dave, thanks so much for taking some time this afternoon to chat with us.
And, well, thanks for inviting me.
Oh, absolutely. And so Dave and I go back a number of years. Dave came down and visited us at the National Severe Storms Lab when I worked down here. I'm sure it was not his first trip down, but it was after I had not been at the lab very long, and we've stayed connected quite a bit over the years since then. And Dave has a very interesting background in research, both in government and academia. So I'm just going to turn over to Dave. And I think him giving an overview of his career, I think will be a good segue into some of the topics we want to talk about.
Sure. Okay. Well, I'll just dive right in then.
Yeah.
I got my PhD in atmospheric science from York University in Toronto, and then went right to a government position with Environment Canada as a severe weather scientist, and was there 20 plus years doing that work. So I worked mostly out of the King City Weather Radar Research Facility, just north of Toronto. And the radar right there outside the window, and all the radar scientists around me. And so really got to know radar quite well. I put in my 10,000 hours of radar observations, and feel pretty good about. I feel pretty confident when I see severe weather on radar that I know what I'm looking at, which comes in quite handy. While I was there, I had a real interest in tornado data, because a lot of the work that we did relied on a high quality tornado database, which didn't exist. So there was a tornado database, but it wasn't the greatest quality. It wasn't up to date. So I led the effort really to update that database and get it in shape where I felt comfortable using the data and use it for verification of not just tornado warnings, but also of weather radar algorithms, but also climatology and that kind of thing. But it was always kind of off to the side of what I was doing. My official tasks were more kind of nowcasting and supportive operations that way. And at least on the severe weather side. So an opportunity came up to be involved with something called the Northern Tornadoes Project back in 2017. And I have a colleague here at Western, Greg Kopp, who's a longtime wind engineering professor. And he and I have actually worked on damage surveys for quite a long time, probably going back 20 years. And he and I wanted to start this Northern Tornadoes Project. And it's unique in a number of ways. One, it combines both meteorology and engineering, wind engineering. You don't see that too often, where those two disciplines come together and work very closely. And that's been great. We also have social science that's part of it too. But the other part is the funding, and that comes from a donor. It's someone in Toronto runs a social impact fund, and that person happens to be a storm chaser and storm enthusiast, and really wanted to invest in the severe weather space. And a lot of investment from that social impact fund, BalancedWx, that went into to starting the Northern Tornadoes Project and kind of proving the concept. And then in 2019, we went national with it, and I moved over to Western University. So I've been at Western since 2019, working full-time as the director of the Northern Tornadoes Project.
Yeah, and it is interesting to see that kind of difference between what's going on in the U.S. and obviously we have a long time tornado database that's been maintained by NOAA, by the Storm Prediction Center. But in Canada, and it's probably not. I know it's not a one-to-one comparison, but at least on the weather side, I think of Environment Canada as similar to NOAA. You know, at kind of at that level of government.
Right.
So if you could maybe just, you know, in a couple of minutes, kind of explain the differences and the similarities between how severe weather warnings and observations are handled in Canada versus what, you know, I mean, I know you're very familiar with what we do down here.
Yeah, sure. In Environment Canada, there are 7 offices across the entire country. They're all called Storm Prediction Centers. So Atlantic Storm Prediction Center, Quebec, Ontario, Prairie and Arctic Storm Prediction Center, and then the Pacific Storm Prediction Center. And some of them have multiple offices. But yeah, 7 offices across the country. Each of them issues their own outlooks, their own warnings, their own watches. So it's not quite like in the US where each office is responsible for warnings, but the SPC is responsible for outlooks and watches. Everything is done at these individual offices across the country. It's a tough job because usually it's 2 people on the severe weather desks in each office. And, you know, say in the Ontario office, you're looking at 10 radars.
Oh, gosh.
Across the area of responsibility, that's more than 1 million square kilometers. So, you know, there's a lot more dependence on automated detection, automated storm ranking, these kinds of things to help the forecaster manage all of the radar data and all of the data coming at them. You know, it is a lot for forecasters to handle. So, you know, that was part of what I was doing when I was in Environment Canada, is trying to come up with tools to help filter through all that information and make sure that what's in front of the forecaster is the highest quality possible. And radar is a big part of that too. Obviously, you know, the best tool when you're in severe weather warning mode is radar, and trying to get the best quality radar images in front of the forecaster was a big driving force with the kind of thing I was doing.
So I think that's a perfect segue into one of the main stories going on that triggered me to think that this would be a good time to get you on one of these videos, which is, so before I left the lab, before I retired last year, we had been working with some folks at Environment Canada on y'all's radar upgrade. You all obviously were going through a major radar upgrade to, and if I'm saying anything wrong, please interrupt me, but essentially to upgrade older C and S band radars with a completely new fleet of S band radars, which for those of our listeners who are not meteorologists are essentially, S-band radars are what the next rad radars are here in the States. They're basically considered kind of the top of the line radar system to serve as the backbone of a regional or a national radar network. So Dave, I guess how long ago was the decision made to upgrade those radars, and over what period of time did that upgrade happen?
Right. I think the decision was probably made something like 10 years ago.
Yeah.
There was going to be rust out issues with our C-band radars. There was only just the one S-band at McGill, the historic McGill S-band. I think it was originally U.S. Air Force, so I'm not mistaken.
Yeah, I think you're right about that. Yeah.
The rest were C-bands, and you know, they had their advantages. The beam width was really small, but the attenuation problems were really not great. So in the range also not great.
Right.
So anyway, upgrading to the S-band was part of the decision, and also it's dual pole as well. So we're right up there with where the next rads
Right.
are as far as
Right.
the instruments, right?
Right.
Leonardo, it used to be Cellx, but Leonardo was the vendor that provided the radars. They're out of Germany, and they're really high quality radars. So it took, I think, 7 years from start to finish for the whole process of upgrading the radars to be done, and it just finished a couple years ago with the last radar being installed. Yeah, and so we've been. It was kind of difficult in transition there because you had some radars that were new, some were old, different time intervals. That's another difference across Canada with the radars, is that they're all synchronized, so that it used to be every 10 minutes you'd get scans. The forecast office has no control over the radars at all. Not even, and now we've gone to it. You don't even have control over whether it's summer or winter patterns that you're using. It's just the same rollout across the country for the most part. And now it's updated every 6 minutes is the update cycle. So yeah, I mean, and I was part of the team that helped to design that. I was very familiar with what the forecasters needed on the severe weather desk, and so I think my input was kind of important to that process. Coming up with the shortest scan possible, getting the most out of that 6 minutes, that kind of thing.
Right.
But there were problems. One of them was with EM interference. That's a problem that's mostly been ironed out in the US, I think through agreements, if I'm not mistaken.
Yeah.
Whereas when we got these new high power radars, I think it went from 250 kilowatts to 1 megawatt power. Right. All of a sudden there was interference everywhere. And it looked kind of like laser beams coming out from the radar.
Right.
It was really a mess. So the radar science team that I used to work with at Environment Canada got to work and solved that problem. And there were other problems with data quality that they solved as well. But there's still a lot left to do. As you know, like it's taken the WSR 88Ds, they're 1988 vintage radars.
Right.
And it's taken that long to squeeze all of that value out of those radars, right? And it's radar science that scientists that do the squeezing. Right. And make sure that those radars are producing everything possible for the forecasters, right? And so that process really had just started with these new radars. And I'll stop there and let you interject.
Yeah. So as Dave alluded to, since the next rad, the WSR 88D network in the US was basically installed over a several year period in the mid to late 90s. And we have always had a large group of scientists and technicians who have been responsible for not only maintaining and keeping the radars operating at their best level of performance, but also at, as Dave said, trying to squeeze everything out of the radar data that we can. So we have the Radar Operations Center here in Norman, which is primarily technicians, but also a lot of meteorologists and engineers who basically work together on that. And then at the Severe Storms Lab, there's a whole nother group of scientists whose job is to do research to essentially try to, like you said, develop new algorithms, new techniques, utilize the radar to better understand what's going on atmospherically, hydrologically, and then hopefully feed that back to the rock and to the Weather Service to improve things. So my understanding is that was the general plan in Canada, that you rolled out these radars, and then the radar team was going to do their thing, like what happened down here. But apparently not only was it not a situation where like what we've been dealing with, where the administration is proposing to dismantle NOAA research and a lot of this stuff. It sounds like Environment Canada just did it. And basically presented the public with, we've disbanded this group. Is that right?
That's partially right. They didn't present anything.
Right. They just did it and waited for people to figure it out.
And I don't think people would have figured it out, because it's not really a public-facing function, right?
Right.
It's more they interface with the forecasters interface with the public, so that it was kind of behind the scenes. But well, okay, I'll start at the beginning of this, which is there are these big budget pressures in Canada, partly because of what's going on in the US. And that is that we've had to really invest in the military and a number of other areas that are important for our trade and our sovereignty, for obvious reasons.
Right.
And that has taken money out of other areas. And so they did a big reorganization on the science side of Environment Canada. And when they did that, my old section got reorganized out of existence, and the radar scientists got reassigned to other things that aren't radar related. So quietly, the radar science support disappeared. And there were a number of us across the country that just couldn't believe this was happening. You just install this expensive and top quality radar network and then dispense with your radar scientists who are going to spend the next 20 years getting the best value out of this thing. So there was a letter that we wrote. All of the kind of the power users of radar across Canada sent a letter to the minister, very tactfully saying, hey, this wasn't a good idea, and here's why. And didn't get a response. And so we thought, okay. So we started a public letter writing campaign, and there's been almost 10,000 letters sent to the minister and to members of parliament about this issue. Still didn't get a response. Then the media picked up on it, and it's been in the national newspapers. I mean, the prime minister must have read the story that was on this. It was page 3 of our national newspaper, and still no response. So I really don't know what's happening over there, but it's not looking good. And there have been other cuts too. That was on the research side. On the operational side, they cut weather radio.
Right.
Just turned it off. And it certainly was expensive to run. I think the motivation there is that, well, we've got cell phones everywhere. We don't need weather radio anymore. And that might be true in the city, but a lot of people who are doing backcountry camping or even just car camping a lot of the time, there's no good cell service, and there was good weather radio service. So there is a backlash with that too. There's a petition going around trying to get it restored. I mean, I think it makes sense to keep it restored or to keep it running for remote areas at least.
Right.
This is a public safety issue, right? And it's the same with the warnings. Like the quality of the radar data in the vicinity of a mesocyclone on the Canadian radars is not anywhere close to the quality of what you get out of the NEXRADs. It could be, and so that was something that was going to be worked on, and also like an extra low-level scan to get 3-minute data instead of 6, right?
Right.
So these were things that were planned to be worked on, and now it's not going to get worked on. So that is a public safety issue, right? The quality of the warnings, the accuracy and timeliness is just not there. That's another thing we do with our Northern Tornadoes Project tornado data, is we've been providing report cards for Environment Canada on their tornado warnings, which, I worked for 20 years in Environment Canada, and I never saw the tornado warning verification numbers.
Right.
They were not shared because they were so bad. When we actually did the independent analysis with our own data, it wasn't good. It was a failing grade using the Environment Canada targets that they have internally, which are modest, really. But we've done 3 report cards now, and it's been improving scores with each report card. So I think we're making progress there. But you know, without the high quality radar data, it's really hard for the severe weather forecaster. Like, they're going to want to wait for that next scan. If what's in front of them isn't clear, they're going to want to wait for another scan. And we've got, you know, a 10-minute target lead time with tornado warnings. There's just not time to wait 6 minutes.
Right.
So, yeah.
Yeah, there's so many parallels here, and I'm trying to decide which is the best way to start. Well, I'll stick with the data first. So, I mean, this is one of the things that's been very concerning for me with a lot of the cuts that have been going on down here, is that I think that even people to some extent within the weather community, I mean, and obviously, you know, talking about the broader general public, there's not an appreciation for what goes into producing quality radar data. I mean, I will admit myself that until I went to the severe storms lab, I didn't have a full appreciation of what goes into, you know, ensuring quality radar data. And now that I did, I think it's incumbent upon people like me to try to get out there and make people understand that this is in real danger. I mean, and in our situation, it's kind of the reverse. We've had the S-band network for 40 years, 88D, and they're starting to get long in the tooth, and it's getting harder and harder to keep them at the level to which we're accustomed. And I don't think that people realize, number one, the amount of technical experience that was lost with all the early retirements and cuts and stuff in the last couple of years. People that understood that system really well and are no longer a part of it. And then, you know, if we're going to replace it with a new radar system, how do you do that if you don't have the underlying research and you know, engineering skill to, you know, do it in, you know, in a productive way? And I think that some people may be in for a rude awakening who are used to just, you know, calling up radar scope and seeing high quality radar data. That comes at a significant cost. And, you know, if it's cut, it's, you know, and I think that, you know, where there's a, you know, a big parallel here too, Dave, is that once you get rid of those people, they're gone. I mean, it's not like you can, you know, I mean, you can hire somebody new, but they're not going to have the same skill and expertise that the people that you've moved on are going to have.
Right. Yeah. You know, the team in Canada is already pretty small.
Right.
The radar support team. I mean, and I don't want to imply.
But when we say small, how small are we talking? Just so compare.
Well, you know, I think at its peak it was probably about 10 people.
Okay. Yeah.
Some of them were research scientists. Some of them were physical scientists that more support function. But, you know, there's also been retirements. Right. I don't know if you know Paul Joe or not, but
yeah, I know the name. Yeah,
he's a pretty well-known and respected radar scientist that basically led the group for a long time, but retired quite a while ago, and they never really filled the position.
Right.
And there are other retirements as well where they never really backfilled them. So it was not only small, but it was getting smaller.
Right.
As we're getting a new network.
Right. How many radars are in the new network?
32.
32. Okay. See, I mean, like here for, you know, those listening. I mean, here in the States, we have, I think, about 150 radars. But we also have, I would get, I mean, I don't know the exact numbers between the Radar Operations Center and the people that are working on radar at the lab, but I mean, it's certainly, it's probably somewhere in the 50 to 100 range, I would guess.
Yeah, in Canada, we have the divide by 10 rule. It's whatever is going on in the States, just divide that by 10. That's what we get here. So,
well, and I know part of the issue, and I don't know that this is something I think you and I have talked about this a little bit in the past, but with climate change, I mean, there is some evidence that tornado activity and flash flood activity for sure are, shifting to be more and more of an issue in Canada, and that would seem to be an added reason to not want to be cutting these sorts of positions right now.
Yeah, no, exactly. And like I was going to say, I don't want to imply that there's not going to be any support for the radars at all. There's going to be the maintenance function, and
Right.
people will order parts and replace them, and
right.
keep the lights on. But
Right.
as far as improving the quality of the data, which at the moment isn't optimal, and starting to think about the next generation too, right? The phased
Right.
array or whatever comes
Right.
next.
Right.
You need the scientists and engineers to be thinking about these things, and without it, you're pretty much stuck where you are, and it'll just stagnate.
Yeah, absolutely. And with regard to the weather radio aspect of it, I mean, I think it's basically a very similar debate here. Right now, I think that there's still a lot of political support for maintaining the weather radio network, and but it's really expensive. I mean, even when I was still a meteorologist in charge in the Weather Service, and that was more than 10 years ago, it was rapidly eating a big part of the budget. And I can imagine it hasn't. I mean, I know they've done some things to try to start leveraging wireless internet and satellite internet and things like that, but I'm sure it's still a money sink. And there are a lot more messages going out on cell phones, but there are a lot of rural areas that don't have cell phone coverage, and so it's really going to be interesting to see. I've been interested to see the reaction here when people hear about what's going on in Canada with weather radio. I mean, it's a mix. I mean, there are some people who are basically like, what do we need weather radio for anymore?
Right. Yeah.
But there are a number of people who, not only, understand the rural nature, also understand that cell phones can be overwhelmed. Cell phones, you can lose service, So it'll be a really interesting to see how that plays out.
Well, I'm getting the impression that people didn't really know that weather radio had been turned off. It was done in March, and there was, they made it public because that they were going to do this because it's a public-facing function, right? So they did that. But I don't think people realized that it happened, because I'm starting to get emails from people now that say, I was just backcountry camping and there's no weather radio. What happened? So, they're starting to realize this service is gone.
Yeah. Well, do it in the winter when maybe there aren't as many people out in the backcountry, Although I know y'all up there, you go back, cross country skiing and stuff, but still it is, I remember when I was still in the Weather Service, we would sometimes talk about, if we want to know whether people are really using a weather radio, just turn it off and let's see what happens, And
and that's, it's possible that that's what's going on here, maybe. But I do know that, we have fatalities every year in campgrounds. We've already had one. We've already had one this year. Just the other day, there were storms up in central Ontario, went through a campground. Someone got killed by a falling tree. This is why you need weather radio in these campgrounds in more remote areas. It's it's a public safety issue.
Yeah, absolutely. So, let's talk a little bit about the report cards and the warnings, because I do think that's interesting. And actually, when I visited up there, when you all were working on developing the CSSL a few years back, I think that was right after the first report card had come out. And I remember that there was some angst among your colleagues at Environment Canada about that. And, you know, since I've retired and I've been, you know, doing the Substack and doing some other, you know, kind of media type things, I've definitely been hearing from a lot of former colleagues in the Weather Service who sense that the warning program here is not all that it could be. You know,
Right.
that there are definite issues, and so I wondering what. So, was the motivation for that just the recognition? Because in talking to some of my retired colleagues, I think that we feel like that there is some need for a more independent group of people to be trying to keep the, you know, not. I mean, we all love the Weather Service. We all work for them for, excuse me, for decades, but we also recognize it's not going to get, that issues aren't going to be resolved without some sort of, just being honest, public pointing out that you've got issues. And I mean, so was that the primary motivation?
Well, let's just say that a lot of times we go out in a damage survey and talk to the people who experience damage. And they say, yeah, we were all standing out in the street talking to each other about the damage we experienced. And then the warning came over the phone for a tornado. So obviously that's not ideal.
Right.
And, you know, in a lot of cases, no warning at all. So, you know, we had the data, the public, the warnings are all public data.
Right.
So we thought, okay, this is something we've got to do. We've got to, I think we can help to improve this just by showing what the skill level is really for these warnings at this point, what the accuracy is. And yeah, there was some unhappiness at Environment Canada with this. And I think it was mostly with the managers, though.
Right.
They said, "Oh, you don't know how to score it properly," and so we ended up doing a peer-reviewed paper on it and said, "Here it is. It survived peer review. It must be okay." But at the front lines, at the severe weather forecaster level, I think there was an appreciation for it, because when you do a forecast, any kind of forecast, you want verification. You want to know how well you're doing with it, right? Yeah. And not just that it goes into a black hole and you don't know how well you did. So, you know, we didn't just offer the report card, but also some recommendations, you know, some feedback on how we think it could improve. And it was clear doing the statistics that it wasn't going to improve unless they issued more. It was like statistically impossible for it to get better unless they issued more.
Right.
And so that was one of the recommendations. And when we did the next report card, just a year later, they had doubled the number of tornado watches and doubled the number of tornado warnings that were issued. And suddenly their scores were better, right? Passing grade. So, you know, it's those kinds of things, right? That I think it's mostly the forecasters themselves that benefit from getting that kind of feedback. You know, it is national level. We keep it at a national level. We could go into regional level, but that gets political really fast.
Right.
So we gave all of the raw data to Environment Canada and said, hey, spread it out to your regions as you see fit, but we're keeping it national here, and provided the national scores. But like I said, you know, it's been great to see the improvement with each one. We were hoping for that, and it has happened. You know, there was still a problem with missing even EF2 tornadoes. There were 29 missed EF2 tornadoes between 2022 and 2024. And so I did a little conference paper on what the radar looked like for each of those tornadoes, just to see like what is the problem here that's preventing issuing for these strong tornadoes. And it was kind of surprising. Like a number of them were completely out of radar range. So, I mean, our radar network covers 99% of the population, but not 99% of the severe weather.
Right.
So the occasional tornado does happen completely outside of radar range, and there's not going to be a severe weather forecaster who's going to issue a tornado warning without radar, I think. And then some of them were kind of on the edge of radar range or on the edge of Doppler range, couldn't see that well what was going on. But the two issues that were the biggest were the data quality. A lot of second trip echoes for the radar geeks out there that were contaminating the areas of interest, and also just the general treatment of the velocity with the Canadian radars. As I said, it needed improvement in high shear areas like a mesocyclone, and so there was always dropouts. In fact, we started calling the dropouts in the middle of a mesocyclone the Canadian TVS, because it's like whenever there's a big dropout in the middle of a mesocyclone, you knew bad things were happening.
We used to do the same thing here in the early days of the 88D. Data dropout at the center of the meso told you it was bad.
Yes. So those are the kind of issues that were preventing a warning from being issued. There were also some issues around radars being down when the severe weather was happening for various reasons. So anyway, it was kind of more understandable after you went through it all why tornado warnings weren't being provided for some of these, larger scale tornado events. Again, we made recommendations based on that. One thing we'd love to see is another tier of radars above the current radars, another tier in the north, because with climate change, it's just going to be moving more and more north, and we're seeing that in the lightning data, we're seeing that in the tornado data. So we need radars up there.
Yeah, I can definitely see that. And I mean, coming full circle, if radar data quality is one of the biggest issues, obviously getting rid of the radar scientists whose job is to improve the radar data is not going to help any of those situations at all. So when you say that the warnings got better, are you talking about lead time, probability of detection?
Combination.
Okay.
The scores were based on probability of detection, the lead time, and both of those targets were Environment Canada internal targets. Like the pod target was 50.5 basically. So like I said, a pretty modest target, but still a target. So we were scoring on that. And then we also, I think 10% of the score was there a tornado watch issued before the tornado warning, right? So people had time to prepare before they actually had to take immediate action. And so, that's how it's scored. And it's a pretty fair scoring system. It's it's not very strict or hard. And I think, like I said, providing that feedback to forecasters is I think really important. When I operated a research support desk next to the operations severe desk for like 15 years when I was working at Environment Canada. And it was kind of inspired by I think it was called Science Support Desk in the SPC, right?
Yep.
Yeah. So I went to a spring experiment a long time ago, 2003 maybe, and there was that Science Support Desk, and I thought, I'm going to bring this back and see what I can do with it. So I had a research support desk set up. And so I could see what the issues were on the research desk, and so that really informs a lot of the things that I pursue. Is like I know what the scientific and technological bottlenecks are for severe weather forecasters, and there's a lot. So just trying to take these on, and radar is obviously a really big one.
Yeah, and I mean that's That's why, the NSSL reorganized a couple of years ago, but before the reorganization, I mean, we had a whole division that was just radar. I mean, that was their focus, because, as you said, it's the key tool. I mean, it's the key remote sensing tool for, severe convection, flash flooding, all of that. And it's, while we're getting a lot of new things, it's still going to be the main game for quite a while.
Yeah, and I get the impression that's not well understood by the people making the decisions to reorganize and cut. It always seems like the models are the sexier things to invest in, and now they're putting AI and hybrid AI NWP models. That's the real sexy thing to be investing in. But I don't think it's realized that when it comes down to the warning decision, you're not looking at models all that much.
No, right.
You're looking at radar, and you're hoping to get some calls in from reports of ground truth, right?
Right.
And I just don't. I think there's an understanding gap there that I think a lot of people don't understand how important the radar is to warning decisions, and because when you hear them talk about the model improvements, they always say it'll improve severe weather warnings, and it's like, I don't think so.
No, right. I mean, and even here, I mean, obviously warn on forecast is a big thing, which, is, but I do think that, well, I think a couple things. Number one, and I think this was recognized pretty early on, but it was also recognized that the horse was out of the barn, that warn on forecast wasn't really, it was a misnomer, because it wasn't like you were going to start issuing tornado warnings based solely on a model. That was, that might be the goal, but that's like the 25 to 50 year goal. That's not something that is going to, it's coming rolling down the pike.
Right.
And, the other thing that I don't think that people recognize is, even with something like warn on forecast, it really relies heavily on the radar data. And if the radar data is crap, garbage in, garbage out.
Exactly.
As we, I know it's one of the first things you learn as a meteorologist dealing with weather models. If the data going into it is no good, and so I think that's something, because it's like you said, it's not sexy. Radar data quality, it just doesn't, it's not something that necessarily anybody's wanting to invest millions of dollars in from a political perspective, but it's really, really, really important. And without it, I think we're in danger of slipping in a lot of areas of the weather enterprise. And hopefully you all will, at some point, some politicians will come to their senses and, maybe get something going again up there. I mean, has there been any, I assume, there, at this point, you're just hearing crickets, right? Just no real response.
There's been, like I said, the media have latched onto the story, which kind of surprised me, because, like you said, it's kind of it's not the most media friendly issue, but you frame it as it's a public safety issue, and then they kind of get that more. And I've seen the response that they've issued to the major media in Canada, and it's basically, don't worry, we know what we're doing. So that's all we've seen. We haven't got an official response back yet. I'm hoping they're working on one. I've heard rumors that they're working on one, but we haven't received anything yet. And so, fingers crossed. Sometimes good things happen.
Yeah.
And in this case, it has to. I mean, we can't have a new radar network like this and not have people scientifically supporting it. So one way or another, this is going to get fixed.
Right.
And I'm hopefully it's through Environment Canada. I mean, the Environment Canada radar science program, or the team, goes back to the 70s, maybe even before that.
Right.
You know, and a lot of pioneering work that Paul Joe and his colleagues did, uh, developing Doppler radar for use in Canada, dual pole as well. A lot of work there. You know, it's just it's kind of sad to see that a team that has that much history, that's been such a big part of how weather warnings are done in Canada, just could be just brushed under the carpet. You're
Right.
done.
Right.
And you know, no press release, nothing. It's just you're gone. It was kind of sad to see that. And you know, when you work inside the government, and I know this from experience, there's not much you can do about these things,
Yes.
unless you really want to put your career completely on the line. So as someone that used to be in government, is now outside, and is pretty familiar with the radar issues, I kind of felt like you know, the responsibility fell on my shoulders to say something about this, and that's fine. I'm happy to you know, to push back on that as tactfully and as forcefully as I can, and hopefully something good comes out of it.
I am very familiar with those same those same feelings, Dr. Sills.
Yeah,
So well, we've got a few minutes left before we finish up. Let's talk about maybe some more positive stuff. So you know, you talked at the beginning that you moved to the Northern Tornadoes Project several years ago. So and I know that there's work going on, you know, spinning up and developing a severe storms lab in Canada that, you know, I assume it's meant to be, at least on some level, kind of like what we have with NSSL and what Europe has with ESSL. Can you just talk a little bit about, you know, what the plans are and what you all are hoping to accomplish here in the next few years?
sure. Yeah, there's just so much, really.
Yeah.
It's hard to keep tabs on everything that's happening. The team is. I was on a training session the other day, because we do training in the spring for all of our people going out in the field, and
Right.
the hail project, they're out chasing storms and collecting hail. With the tornadoes project, where they're out doing damage surveys, and we had 46 people on the call. It's like,
Wow.
wow, this is getting big.
That's awesome. That's really cool.
So yeah, we've got, you know, with the Northern Tornadoes project, we're looking basically at all convective wind events. There's the Northern Hail project that was stood up in 2022, and that's looking at hail mostly in the Alberta area, because that's where the main hail problem is. You've got high population density there, and a lot of hail producing thunderstorms in Alberta. It's kind of like Colorado environment wise there, just off the Rockies. So you get some really interesting events and big hail. So they're out there, you know, basically they want to get their hands on the hail as soon as it falls.
Right.
And you have to basically storm chase to do that. So there's teams out there doing storm chasing, and then getting right in behind the storms and collecting the hail. And you know, they've got thousands and thousands of hailstones that they've got in a cold lab that are waiting for analysis. Awesome. We started lots of northern things. We started a northern mesonet project. So this is a network of networks kind of project. I didn't realize, I don't think anybody realized, there were 3,000 plus weather stations across Canada reporting live.
Wow.
Yeah, it was really surprising. And that's not even including the personal weather stations.
Right.
That's just like various networks, fire network, electrical grid network, whatever. So we're collecting all that, putting it in one place, having a really nice viewing tool with that, and then archiving it as well for case study purposes and that kind of thing. As well as investigating new technologies for weather stations that will allow us to better observe extreme storms. So rain gauges, wind sensors, hail sensors. We found out in our 2022 derecho through Southern Ontario here that the wind sensors and the way the wind data are collected across Southern Ontario, actually across Canada, isn't great. With the sonic anemometers, as soon as you start getting rain and hail as part of the mix with the wind, the quality goes down, and then they start throwing out values, including some of the best gusts. In other places, the power went out before the storm got to the station, and so the communications were cut off, and then there was no backfilling once the the electrical came back on, so you lost all the data. So yeah, I mean, there's all these issues that we can do better with to sample extreme storms, which we're getting more of for sure. So that's part of it as well, setting up these small networks, dense networks of evaluation, cutting edge instrumentation that we can evaluate, and working with various partners on that as well. So those are the projects. We're also planning to stand up a flash flooding project, because that's kind of the last hazard associated with thunderstorms. We're planning to do that next year. But I think you'll find interesting that with the Northern Tornadoes project, we've got a couple projects, sub-projects that are looking at ways to rate tornado intensity beyond the EF scale. One of them, and you'd probably be familiar with this, is using tree fall patterns to assess the wind speed with the tornado. And yeah, we've ran that basically. We've developed the machine learning model, ran it across a lot of our tornadoes where we have high resolution data, and we're going to actually be able to upgrade a lot of our forest-based tornadoes to.
That's awesome.
I think we've got some that are going up to EF4.
Wow.
Based on this method, and so this is really going to change our climatology. And we've got a number of techniques we're working on, but this other one is the debris flight model for large objects. And so this is kind of on the wind engineering side, but it's important for tornado analysis. So we've got things like vehicles, combines, hay bales, these kinds of things that are flying through the air. And if we know where it started, where it ended, how it flew, we can model that and estimate the wind speeds. And so this was published. Connell Miller was the lead on that. He's the director of the Northern Mesnet project. And I guess the people at I think it's the Bismarck office in North Dakota caught on to this and said, hey, we've got a tornado that's rated EF3, and we could go to EF5 based on this tanker car that got thrown.
Yeah, the Enderlin tornado.
Yeah, so they asked us for help with that, and we worked with them, and sure enough, first EF5 tornado in the U.S. in 13 years.
Yep.
And yeah, it's a really interesting case, and I did a whole bunch of radar analysis on that. Just we were invested in it, right?
Right.
And in the end, it's Connell and I are gonna be doing a paper on it at the Storms Conference coming up. So.
Oh, that's awesome. I will. I'm not going to be at Madison, but I'll look forward to hear about that. Maybe I'll have to register to do hybrid, because I looked at that case quite a bit too, because that was not too long after I retired and started all this, and it was a very interesting case because it certainly, from a radar perspective, seemed like it was stronger than an EF3.
Yeah.
And so it wasn't overly surprising when they, but you have to have, you have to have a reason. I mean, you have to have some evidence to support it. And that's why the work you guys are doing and others are doing, with, machine learning techniques and being able to, I know there's a lot of work. Several researchers are doing, different work here with drones and flying, different instrumentation. A lot of people at the lab, Tony Liza and his folks, doing a lot of really good work. So there's a lot of exciting stuff going on in that area that I think is really going to help us understand the damage and help us understand what's going on.
Plus the new EF scale standard that's hopefully going to come out next year, maybe.
Right.
I'm on the committee.
Yeah.
For that, along with Tony Liza and a bunch of other well-known people. And we've been working on this, I think, for 6 years now, maybe.
Yeah, it's been a while.
Maybe longer.
Yeah, I think it's been longer. Yeah.
Yeah, and it's just about there. But it's the idea was to get it into a standard. So it's the American Society for Civil Engineering is the standard, right? But that's a pretty tedious process, the balloting and going back and forth with the balloting and fixing, and this hasn't even gone to the public balloting yet. So it's going to be a pretty long and tedious process to get this out there and in use. But we do plan to adopt it here in Canada, and I know the same is true in the US. So hopefully next year, maybe the year after that, we'll have a whole new set of EF scale DIs to use, and a lot more I think right now it's a 500-page document or something like that. But there's a lot of specialized chapters.
Yeah, right. But there's a need for that. I mean the whole deal with that Enderlin tornado, and I mean, not there's pros and cons to all of it, but I mean obviously I go back far enough where I was rating tornadoes on the F scale, and I mean we would have just said, well, we would have consulted with a couple of engineers and say, well, this is probably about the wind that it would have taken to throw that thing, and it's an F5, but in the EF scale there's more we're trying to be more rigorous, so
more rigorous, more precision, hopefully more accuracy with the wind speeds, although it's starting to come into question now. Now that we're doing more engineering studies of this stuff, it's like, those wind speeds are kind of low with the EF scale. So who knows? But I think it's a good approach, and the work that we're doing on that committee and what the new EF scale standard will look like, I think it's all good stuff. And it's going to have chapters for tree fall, chapters for in situ measurements, forensic measurements, radar measurements. So all of those chapters are going to be included in that, and that's why it's such a long document. But just fascinating work, though. Just trying to get one method to agree with another method to agree with the other method is the hard part.
Yeah, one of the things I miss about being retired is sitting with Dr. Liza and talking about these sorts of things, because it is really fascinating. Yeah, absolutely. Well, Dave, I've kept you for almost an hour. Probably should wrap up here, but I really appreciate it. It's been fascinating. Hopefully people will find it a fascinating conversation. I certainly did, and I really appreciate you taking the time. And for everybody out there, Balanced Weather subscribers, thanks for joining us today, and we'll talk to everyone soon.